Hi, I've been doing some episodes for these ESP32 Adventures, and I decided to do another little video here because I'm actually working on completing the library for keyboard input on ESP32 S3 type controllers that have an OTG host mode. And the first thing I've done is this is the actual host USB port on there. Of course, it'll work just as well with one of these DevKit C on one of these USB-C with a little adapter. It'll work just as well. And in fact, any one of the USB ESP32 rather S3 versions have this OTG mode, which they should all be able to be used in that way. So the first thing I've done is I've made out a little breakout board here so I can hook up a logic analyzer, and I've got two logic analyzers. I've got this cheap one which I evaluated I think about a year ago maybe, and we're going to be using that one in a minute. But I also have this one over here, which is as part of my oscilloscope here, and it has a cable to connect these little connectors there to a circuit, and then you can get the input. I've already done that, and as you can see on the screen there, I've got some inputs, and we'll look at that, but we're going to be analyzing it with this little cheap one. I think I paid $20 for two of those, and they work with Cele Logic or something software, and that software is actually more sophisticated than what the software in the oscilloscope is. That particular oscilloscope does not have an analyzer for USB, and so it makes it hard to decode. But in any case, we'll get into that. So the first thing that I was looking at is I found this library, as I said, on GitHub for keyboard input on the host, but the software did not appear to be complete. So this over here, as I explained in the episode when dealing with this, I took the two files that were on the GitHub thing, and I'm not using it as a library right now. I'm actually using it as part of my software applications over here. So I put the CPP file in the source folder, and I've got the header file, the matching header file, in the include folder in platform IO. And the actual place where this is actually reporting the keystrokes is actually over here. And the first thing that I noticed was that there was a comment there, hit key numlock to do. And I put that comment in there, and I've put some extra comments in there. So it is actually coming through over here, and I actually fixed that numlock thing is now actually being reported. But also I found that it was only reporting as a modified shift key, and it wasn't reporting the old control. And in fact, the Win key on the keyboard is also a modifier. Comes back with binary 8 on the left and something else on the right if you got one. Most keyboards just have one Win key on the left nowadays. So I added this code over here, and I put I had some fiddling with some extra code over here, because that Windows key, if it is pressed by itself, there is actually a scan code for it. So I'm wondering whether I should output the scan code or just leave it as a modifier. In any case, so I'm still looking into that. But in order to find out and there is stuff in this, like it has some spaces for a gamepad, but that hasn't been filled in, and I don't need that. And also there is a in the header file there is a whole table there for Japanese keyboards, which I don't need also. So I've got some work to do on this software before I'll put it on GitHub when I'm finished with it. But in any case, what I wanted to report now is that I have been looking at the information that's coming out of the USB port and the HID file, and in actual fact this is all described in this document, which I've also highlighted, and there's a link in one of the episodes for that, but I'll put another link in here for it as well. I'm not actually calling this an episode in the ESP Adventures. This is just an extra thing that I found out. In this document there is this protocol layer, and it shows you the type of packages that are coming out on the data packages on the USB wires, and we are going to be looking at the in, and it reports with data 0, data 1, and we'll see an ACK and a NAC there. And I found out that keyboards respond in different ways. I've got an older Lenovo El Cheapo keyboard which seems to respond, so the host is actually responsible for polling the keyboard. The keyboard does not actually volunteer its information until it is actually told to do so, and that's where this in packet comes in. So it says to the keyboard, hey, you got something for me? And the later keyboards seem to just go NAC. It's very quick, but some of the El Cheapo keyboards, they seem to come back with a report with all zeros in it. I don't know why. Perhaps there is some newer chipsets or something to do this keyboard stuff, and they're dealing with it on a better way. But I remember many years ago with RS-232, the specification also was a bit complex and very vague, and all the engineers just actually interpreted their ways, and it was a nightmare. Some were using different pins for different purposes and so on, and perhaps over here too somebody took shortcuts. So I'm not sure, but it's interesting anyway. So this guy over here is Ben Eater. He has a video, how does a USB keyboard work, and he goes into the whole thing here about what all these signals mean and how to interpret them at a binary level and so on. We don't need to do that. If you're interested in that, you might as well watch this video, so I don't feel the need to actually repeat that. And we are going to be looking at what we find, hooking it up to logic analyzer just to understand how to interpret these bytes so that I can actually deal with them properly in that software. Okay, there we are. This is actually what is displayed on the oscilloscope right now. And get my mouse going here. So basically what you get is there is these pulse here that actually starts the process off. And then there is a synchronization, which is this bit over here. And then there's actually the in command, which actually comes up over here. And then there is an ID. Each device that is hooked up to a USB port gets an ID, but on the little, since there's only one host port on the ESP32, it always comes back with 1. You'll see that when we look at what these codes mean. And then there is some bit stuffing going on over there, and then there's a response, and this thing probably says NAC or something like that. But as you can see, there is no this oscilloscope is not able to interpret this for us and display, what these codes mean and so on. Okay, so the reason why we're using these little logic analyzer, this little cheapie, is that it does have, because it uses the sophisticated software that SLI Logic supplies, it does have an analyzer that is suitable for looking at USB. And so we can hook that up. So let's have a look. We need D0. Now this thing can handle up to 24 megahertz as far as I know, but it's defaulting to 12, but that's plenty fast enough for what we are doing. Okay, this is 1. So we can get tangled up here. This is number 1, and this is number 2. Okay. I think they're actually numbered from 1, not from 0. And then we have a ground. Right. So we can hook ground up to here. We're going to hook number 1 up to, which is actually going to be D0 on that screen, up to the D plus, and this is going to be the D minus. Alright, and this thing here that's plugged into the USB. Okay. Connection completed. And what we can do now is, I have already uploaded the software in here, and if I turn it on, it's got a little battery connected. And if I hook up a keyboard, we can move that up here. I'm first going to use this little keyboard over here. Goes into my little adapter board I made up, breakout board. You can see the keyboard is initializing. That's what it does. It's like it's got backlights. So if I hit a key like A, it's actually reporting that on the software I put in there. The hit key code is 4. There's no butterflies because I didn't have any control alts and so on down. It's character lowercase a, and there's no name. If I hit a like caps lock, now you see, oh, I accidentally hit the insert key on with my wrist over there. It has names. Okay, so that is working from that respect. So now we want to let me change the camera. Okay, see a little bit what I'm doing over here, but let's go and look at the software here. Okay, so we're in the software now, and we are connected to our little logic analyzer. Excuse me. And I can actually start. We have our analyzer connected, which is there's a bunch of those. I2C, SPI, asynchronous serial, even addressable LEDs. I didn't realize I had a special protocol for that. Some sort of Atmel thing, which I'm not sure what it is. CAN bus, even HDMI by the looks of it. Very useful things. I2S, sound, I2C, one wire. But what we're interested in is the USB, LS, and FS. And that is what we have already loaded over here. So we have D+, As you remember, there is two wires on USB 2. There is the white one and the green one, and that is all that we are using for keyboards. And the keyboard is a relatively low speed device. So currently we have it set for the low speed mode, which is just fine. And so what we're going to be doing is I'm going to hit the A key, which we know is scan code 4, and I'm going to get it running over here. I'll stop it, and then I will bring in the analyzer window here, and as you can see, there is different packages. These are described in this document over here. There's in and that we are looking for. This is a function to host transaction. There's data 0 and data 1 that we're going to actually be looking at. They go from data 1 to data 0 to data 1 rather, so that it knows if it finds two data 0 packages in a row that there's one missing. That's a feature for that. And we'll see ACK and NACKs. A NACK is actually returned by the keyboard saying, hey, I've got nothing to report, no keystrokes, no changes. And ACK says, hey, yeah, I've got something for you. And I have already seen that some of these keyboards respond in different ways. I've got an El Cheapo Lenovo keyboard over there that actually doesn't seem to be coming back with NACKs, which it should do, but it comes back with a report. It says ACK and a report which all the keys are 0, all the scan codes. So in other words, there is nothing to report, and it does that. I don't know why. It's an older keyboard, at least 10 years old, maybe even a bit older. Maybe there are some newer chipsets nowadays that some of the newer keyboards use, and they actually report a little bit better. There is less stuff going on the USB port, wires all the time and so on, but in any case it doesn't really matter. That is how it works. So we have that is the document that you can actually download that. There's a link in one of the episodes that I did on the keyboard host mode, but I'll put another link in the description here. And let's go back to here. Okay, so let's go and analyze this then. Now you can actually go to the different places. So here was an actual interaction here. It was a PID in command, address 1, endpoint 1. If you plug this into a PC, of course, you would get much higher numbers because usually you have lots of USB devices plugged in. And so this was a command to the keyboard. The keyboard then actually responded saying, nope, I've got nothing for you. However, if there was something to report, I know that the package is called data 1 or 0, so I can actually put data in there and see there were two. This one over here said that, see, I have learned that the first byte is actually the modifier keys. There aren't any. I've got no control, alt, shift or win keys down. The next byte always seems to be 0. It must be reserved or something. And then you have a bunch of 1, 2, 3, 4, 5, 6 bytes that can have keys in them. So you've got a 6-key rollover. You can hit up to 6 keys at the same time in one report. If you hit more than 6 keys or some strange keyboard combinations, you tend to get a value of 0, 1, which is some sort of error, and it's a nondescript code. In any case, byte 4, as I said, we know that to be the scan code for the A key, and so that's what I hit. I hit A, and that was data 0, and if you go to data 1, it is now saying, okay, basically the A key is up. See, it's by 0, so there is no more information available. So this is how it actually communicates that key is down, and then you get the code for the key that is down, and then you'll get a when the key is released, you'll get another one that says 0. The key is now being released. So that seems to be how it works. Now when I hit the Win key and so on, you'll see that codes will come up in the first byte. So let's do that. Okay, so let's try. I'm going to do Control A now. So it first reported, I hit Control first, so the first report that came through was 1, that is the control key, and then the next one said it is Control plus A, and then the next one, A is being released, control key is still down, 1, and then finally all the keys have been released. Interesting, huh? So now let's have a look if we hit the Win key. Byte 08, that's the Windows key, which really brings us to this software here. It is not dealing with this properly. I need to change this. So what it is actually doing is it will only report, see it says over here, if the key code is not equal to 0, then it is reporting the actual key code. But we need to be reporting even if the key code is 0, because that's how it picks up when the Windows key is down, or the control key is down, or the Alt key is down. Now when you're picking those things up, then he says, okay, the key code is 0, but there are some modifiers, and if it happens to be the Windows modifier, well then obviously Windows itself, if you're running this as a keyboard in Windows, it actually brings up the start menu. You don't have to hold the key down with it. However, if you're using this Power Toys, one of many of the features there actually uses the Win key as a what do you call it, a modifier. For instance, in one of the commands you have to hold Control, Win and Alt down, all three at the same time, for it to do something. So they're using it as a shift key, as a modifier, if you like. So in any case, as I said, I need to look at this code. It is not right for what we're trying to do, because what I'm actually trying to achieve is that it reliably comes back with all the codes that is coming onto the USB bus for the keys whenever there is a change in keys, and then I can actually process those, and then I want to output the keystrokes again through Bluetooth, because unless I hook up another little USB board to it that can act as a device at the same time, because these controllers over here do not have two USB ports on them. They only, they got two ports on them, a host and a device port, but they are using the same pins on the microcontroller for the D- and D+, so you can't use both at the same time. But one could potentially hang another one of these little USB boards onto it, which I must try, and if that works, I will certainly do a little video on that as well. Where is that thing? Is it in here? Yes, it is. See, there's a little USB device that potentially you could hook up to a microcontroller, and then you'd have a second USB port that's completely standalone, has a chip on there that actually does the protocol and stuff like that. In any case, that is what we have so far. So if I hold all three, Control, Win, Alt and Shift, all four of them down, what do we get? So we got 2, that is Shift. We got 0B, that is like 2 keys down. 0F, it's like all four of them are down. Then I released one again. Then I released another one, the Win key is still down. And now they're all up. So that is how it works. I needed to find this out, as I said, to get that software changed. Anyway, that's, as I said, that's all I got. Don't forget to subscribe and so on. And this is just an adjunct to the last episode I did for ESP32 Adventures. Some more keyboard stuff, and I'm working on the software, and as I said, when I've got that available, I'll stick it on GitHub and you guys will be the first to know. I'll see you guys later.